At Boston Dynamics, we really focus on doing closed-loop control for robots. What I mean by that is it's always learning from the environment and reacting to it. Stretch is our first robot that's really purpose-built for the warehouse. It moves cases all day long, it doesn't get tired, and it doesn't get injured.
The Stretch's morphology is a mobile base with a capable drive system to move in any direction, which houses the compute and the battery power to control the whole robot. On top of that, we call the turntable, which carries the robot's arm, a perception mast, and the vacuum system. The whole system was designed together. It's not an arm bolted onto a base. It's really a single robot. The other thing that makes Stretch special is that it's able to understand the environment and make its own decisions about what to do next.
The robot's really aware of its state and the state of the world around it, and it's reacting even as things unfold away from the ideal. So some people will design robot trajectories that are pre-planned or feed-forward and assume that everything will just go perfectly and you'll stay right on that trajectory. But of course, the real world doesn't usually unfold that way. Even though Stretch looks very different than Atlas, a lot of the underlying technology is shared. We're able to use the same technological building blocks and really create very different types of robots, whether it's a humanoid or a more purpose-built robot like Stretch.
We were doing some internal research on manipulation with Atlas, and we happened to use boxes for this demonstration. When we released this video, we got a lot of incoming calls that Atlas would be perfect for a warehouse and we want to buy one. We knew that it wasn't really the right fit for a product at the time, but we realized that it was an indication of a market need.
We thought, well, maybe we can build a robot that's a little more simple and a little more purpose-built for the warehouse. And that's how we got to Handle.
The initial idea was to combine the best of wheels and legs. Warehouses have very large open floor spaces that are very flat. We wanted to understand what are the capabilities and limits of a system that has that combination of wheels and legs. So we put it through an obstacle course, classic Boston Dynamics style. Early versions of Handle leveraged copies of Atlas's arms on the torso to pick up and move objects. But they weren't really designed for the kinds of range of motion and applications that Handle was really intended to do. Once we started to think more about the workspace needed to do pallet manipulation, box moving, and truck unloading, we reimagined the entire design into something that really suits the workspace of the applications in the warehouse.
So Handle has, let's say, three main components. There's the wheels that it uses for mobility and for balance. There's the tail. The tail, interestingly, is where the battery goes, and that's by design. So as Handle is moving across or reaching across a pallet to grab boxes, the tail acts as a counterbalance so it doesn't fall forward. The third element of Handle is an arm that is designed specifically for warehouses, and on the end of that arm is a vacuum suction gripper, and that enables it to quickly pick up boxes. And we even took Handle out into some warehouses with some early adopter partners and tried to do some real warehouse tasks. The problem was that Handle has to spend a lot of time maneuvering to really do its job.
Imagine trying to do certain things in a warehouse environment when you're wearing rollerblades, and it just slows down the speed of operation when you're trying to, move a box from point A to point B. It's hard to continually have to turn, go, turn.
We could only look where the robot body was pointed, and combining that with the constraints of balancing meant that there was a lot of extra motion of the whole body to move a box from one point to another. And when you're unloading a truck, that's a kind of repeated motion that needs to be as quick as possible.
When we realized that Handle was a little too slow to do the job, we quickly pivoted to Stretch. The prototype of Stretch consists of three main pieces. There's the base, which is about the size of a pallet. There's the arm, which does the manipulation, and there's something we call the perception mast. So that's a tall mast next to the arm that has Stretch's vision system.
The mast is individually actuated, so it can look around independent of what the arm is doing, and it can see what to do next.
The sensors on the perception mast, we can point at anything we need to see, whether it's boxes, pallets, or conveyors, and we can opportunistically take pictures whenever we need to. Those pictures are then fed into a custom-built machine learning algorithm that's able to identify where the objects of interest, like boxes, are in the image.
The arm is a 7-degree of freedom arm, so there's a little more flexibility than a traditional industrial robot arm in order to fit into tighter spaces and have more solutions to move through the space. And then at the end, we have a vacuum gripper that allows us to attach to the box and maintain a good grasp.
The mobile base was really maneuverable. You could drive in any direction you need to see, forward, backward, left, right. You could turn in place, you could do combinations of those motions. So that maneuverability was really a big advantage, especially in tight spaces like the back of a truck or narrow aisles in a warehouse.
So once the prototype of Stretch started looking promising, we started designing the product version of Stretch.
We revisited every component to make sure it was going to be reliable, cost-effective, safe, and have the performance needed for the market. What resulted is a brand new machine.
One big difference is the sound. So we have a new vacuum pump. It's much more quiet. The robot's a lot easier to work around. Another big difference with the product version of Stretch is that it has a brand new safety system on board. So that means it has an onboard dedicated safety computer. It has dedicated sensors that are redundant and enable us to be safety compliant. And it has safety rated LiDARs at the base of the robot that enables it to have a really high reliable way of detecting people getting too close to the robot. The same folks that designed the Atlas robot came on board and designed a whole new gripper that we call the Smart Gripper. That gripper is full of sensing and pneumatic control, and it's able to handle not just perfect boxes, but boxes that may have some damage to them. It enables us to pick up more than one box at a time.
Stretch is continually learning and improving. We're constantly analyzing data that we're getting in from robots in the field. Machine learning, or especially deep learning, is inherently very data hungry. So the more data you can collect, the more images you can capture, the more experiences Stretch can leverage, the better off it's going to do.
Stretch is out in the world, moving boxes every day at multiple sites. We're watching the numbers climb. We're getting rave reviews of its ability to get the job done in the worst conditions. We hear stories of trailers pulling up full of thousands and thousands of 50-pound boxes. This could be in the summertime where the temperatures are over 100 degrees inside this metal box. And those are grueling conditions for the people who are asked to unload them. They're very happy to be able to push a button and have Stretch go in and do that job while they work on other higher value operations within the warehouse.
I got into engineering, robotics, machine learning because I wanted to work on real problems and try to do some good in the world. It's been really cool to see the robots evolve as they become better fit for these applications we're targeting.
For a company that has made its history with exciting robots walking around and doing backflips, you get a very different sense when you see Stretch operating. It's really interesting for a few minutes, and then you realize it's boring. This thing just keeps going all day long and doing real work.
It's really cool to know that the things we're creating are out in the world, they're helping people. And as we scale up, there's probably a Stretch running at all times of the day.